So this is my code for my D flip-flop. Here we see that our inputs are going to be D and clock, and our outputs are going to be Q and Qbar, which is the complement of Q. And once we look at our process, we're checking the clock and updating Q and Qbar, based on what our clock, if our clock experiences a positive edge trigger, and that's shown by here. So when it does experience a positive edge trigger, Q is set to D and Qbar is set to not D. Here is our test bench, and our test bench basically doesn't have any type of input and output ports because we're testing our D flip-flop file, which our inputs and outputs will be represented by the signals D, TB, clock TB, signal Q, TB, and Qbar TB for our outputs. And then we port map our component that we have created at the top here, and we're going to connect that to our signals. We want our clock to move the fastest, and then as our clock moves, we want our D and our DTB to represent our D to move as well, and we'll then assert our Q and Qbar. So here's our simulation. Here's our simulation, and here we can tell Q is here, this is Qbar, this is D, and this is the clock. And so when the clock is on, then we check D, and whatever D is, Q has to be, because Q is equal to D, and Qbar should be the complement, so Qbar is going to be the opposite of Q. So when clock is on, D is 0, then that means Q should also be 0, and Qbar should be 1. When we move on, and the clock is off, that means that there should experience a hold, and Q and Qbar should not change no matter what D is, which we see Q and Qbar remain the same, Q remains 0, and Qbar remains 1. When we move and the clock is now on, we should then look to D, and D is going to be, Q is going to be whatever D is. So when the clock is on, we look to D, D is 1, so Q should be 1, which it is, and then Qbar should be 0, which it is. We then move on. Now that the clock is off and D is off, it doesn't really matter what D is because the clock is off. Q and Qbar should remain the same with what they originally are in their previous states, and we see that by a stagnant here. Q is still 1 and Qbar is 0. Then we move on, and the clock is on, but D is now 0. And so that means that whatever D is, Q should also be, which it is. When the clock is on, Q is now 0, and Qbar is 1. You can see in the change. And we can just try one more. And so now looking at it, the clock is off, which means that Q and Qbar should remain the same no matter what D is. And we see that D is 1, but it doesn't matter. There should be a stagnant between the previous Q and Qbar, which it is. It's 0 and 1, and we see here that it was originally 0 and 1, and even though when the clock turned off, there should be no change. And this pattern kind of goes the same as you go throughout the rest of the inputs, but there only should be 4 separate outcomes, because we have 2 inputs. And when D is off and when D is on, as well as when clock is off and when clock is on. And that is our simulation for the D flip-flop.